Oh, okay. So I'll be talking about firmware, and I will also give you a warning that my presentation is going to be very boring. Basically, no images at all. And the good thing is, everything I say is you'll be able to find on the slides themselves. So it will be easier for you afterwards. You don't have to actually listen to me. You'll just be able to read it later. So anyway, I'm going to talk about firmware. And in this case, one particular firmware and from one particular manufacturer. Oh, as far as you can manufacture software. So firmware actually, okay, here's an outline. I'm running ahead of myself again. So introduction, our research, there's going to be a response about the incident from the company itself. We'll go over that, and then there will be conclusions. So let's start with introduction. So this is probably trivial stuff for most of you in this session, but for those reading this later, it's probably going to be helpful. But basically, firmware is a layer of software that sits between hardware and the actual software that you see when you're using the device. Over the air is an update mechanism that actually happens mostly without user intervention, and you don't have to plug your device anywhere, or you don't have to take it to a service center. It does it by itself. And firmware over there is basically a mechanism where the firmware, this low-level software, is updating itself. So what is ADOPS-FOTA? It's basically a service they provide. If you are a device manufacturer and you suddenly decide, well, basically if you're a company and you suddenly decide to make mobile phones, you basically contact these guys. Oh, we have this, we want this screen, this camera, this case, and all those ingredients. We want to put them together. We need we need to be able to actually run something on this device. So this company advertises itself as the leading in the world. Robust connected service around the world. Yeah, leading. Okay. So basically they provide outsourcing, as an outsourcing service, this firmware as an outsourced service. Yes, that's the term I want to use. So, and at the end of the last year, it was October 28, Cryptowire, company probably, came up with a newsflash, and as part of that newsflash, they quote a claim that they quote an ADOPS quote, but basically with the numbers that this ADOPS company has 700 million active users, and they have a market share exceeding 70% across over 550 countries and regions. Basically, they apparently ADOPS, the company, they own the whole world, all the devices they control. So, but the news flash was actually about this particular firmware and one particular device, and how it is transmitting private device and user information, including full-body text messages, contact lists, call history with telephone numbers, applications that are used by the user and that are installed on the device, also device identifiers and all kinds of stuff that basically the phone should not be sending anywhere, actually. And this newsflash also included a few domains where this information is actually being sent, well, that are actually used. And we will see those later, but what we did is actually, now we get to our research, and we used these domain names to look whether in our constituency, which is public sector in Latvia, whether we have traffic and whether devices are actually also sending data to China from Latvia. So what we found is that traffic is indeed sent over plain HTTP. Post data, there's some obfuscation, but most of the time it looked like this is a legitimate firmware over-the-air traffic. And we also found that this software, yes, it can upgrade itself. And as part of this research, we also get a number of Android devices, although none of them were the blue R1 HD mentioned in the CryptoWire newsflash, but those other devices also use Adobe's firmware. So now we will get into some, not screenshots, these like copy-paste text fragments from console. Basically, what does a request from a device to the China servers look like? So here we can see, again, wrong button. There's a URL. It's sent to this host, which was mentioned previously. And we have some basically hexadecimal string of numbers, digits actually, hexadecimal digits. And it turns out this is not encrypted, no rocket science, it's just a bit scrambled. When you look at the code and then unscramble the numbers, you get data like this. It's like ampersand separated, all the numbers like IDs, Wi-Fi addresses, languages, resolution, and there's also device versions. Basically, details. Some of these fields are empty because we didn't have a SIM card on this device. But basically, a lot of identifying information, including, I don't know, IMCI, like SIM card numbers and stuff like that. Why the data is there? We talked to Just 5, which is actually one of the manufacturers of Android phones. We have their office, their presence here, and we talked to them, and they in turn talked to Adobe, and their explanation was that this data is sent so that for marketing researches, for insights about market share, market penetration. You have numbers like which mobile operators have bigger share of their devices and all stuff like that. Of course, you can get all those numbers from these data fields, except they don't even have to be sent completely. You just need a small prefix from some of them just to know country and operator. You don't have to send the full number. But in response to that request, which we just saw, which was obfuscated, comes back a little piece of JSON with further instructions for the phone what to do. So in this case, this was a legitimate firmware update request, like basically call home, check whether there's a new version, and it sent back some numbers, nothing interesting, like on frequency went to check again, and where actually URL where to check for the update. And this URL is stored on the phone, and next time the request for updates is going to be sent this way. And this is like one of the lower level, also firmware providers, basically chipset manufacturers. But basically, this is where next request will go. And our first idea was, if the communication is done using HTTP, and we know how to decode it, can we actually pretend to be the remote end and feed it some another update, like basically manufactured update? So no, the short answer is no, because on the device. They call package manager install with -R flag, which basically only allows to update or replace an existing app. And the signers, cryptographic, like, you know, they do the checks and everything. That part at least is good. They do some checking, and everything is fine. And we were not able, basically, to feed it an unrelated, like, fake APK. Basically, we tried to install a random APK, not a firmware update, but a random. We were looking whether it will, after downloading, whether they will install it if we feed it anything, and it didn't. But then we looked. So that was our first big fear, that somebody on your network would create a man-in-the-middle attack, and they would basically be able to feed fake updates to those phones. So it turned out it's not so bad. That's actually not so easy, and that doesn't work. So we looked into it more into it. Basically, there are 4 packages, 4 APKs, and I will explain them a little bit in detail further down. Basically, there's like 2, Adobe's Photo and Adobe's Photo Reboot, which this one is like the update management service. This one is a low-level system running with the root permissions and everything. They just basically, they have reduced the attack surface basically by putting it in a separate APK. Probably that's the idea. Then there are like, on this device, there are like 2 other related APKs which appear to be empty. And I would now like you to actually notice the similarities between the APK and package name that's used internally in the package. So for Adobe's Photos, there's like Adobe's Photo Reboot, Adobe's CSOPER, and then there's firmware upgrade. I think it means firmware, but basically they also have those letters in the package name. Anyway, the first one is, as I said, management app that's actually interacting with users. It says like, oh, you have a new update, blah, blah, do you want to install it? And it uses the services of the other one to actually do the work. And then, from another device, we did happen to get another device where this package was not actually empty, and it was kind of like we were very, very, very confused about, as you are now probably, about all the package names and acronyms and everything. Those asterisks are just for emphasis, they are not in there, but basically this is like firmware upgrade provider which should use like com.fw. blah, 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 but turns out it uses like, it pretends to be, if you look in the running applications and services on your phone, you see the package name, the advertise, which they put in the manifest, and they're using like photo, like basically photo CSOPER package name. And this APK also had some interesting other packages, which we'll go into soon enough. And actually, from now on, we will be looking only at this APK, because the previous one we got from the other phone, it looked like perfectly valid, legitimate, nice behaving, nice firmware update software. But this one, this is like really nasty. So this package in the APK, it has package installation functionality. Basically, there's when we reverse this package, we see they're trying to hide something. You know, when you see strings that are like base 64 encoded, and then here's like 3 strings, and this one is one long one, and there's like China Ren, that's a passphrase, and then when you look what this method is, like in the same package, DA, the DA and all those cryptic letters is because I didn't bother to actually rename, because you need proper tools for that, but we don't have them yet. So these are all left as the compiler left them, but basically this is a encryption routine, actually decryption, I think, or encryption, I don't know. No longer remember which one is which, but we can see here initialization vector, the J1, the passphrase is actually in here, it's passed to the method, and it's actually doing encryption, or decryption in this case. And basically, in the end, by decrypting these strings, we get, from the 3 on top, we get these URLs, notice the HTTP protocol, and the last one that was in a separate method, it's a command and control, seems to be command and control URL, basically. And this package, another package, TSC control package, actually uses that URL with some final parts, like depending on what it wants to do. But from getting the JSON back, it can do one of 4 things we've discovered. It can retrieve and install an APK remotely, like just download. Well, this is all not very nice because it's straight from the compiler, but basically you can see strings chmod, it makes it everything executable, everything readable, everything. Just uses, funny thing is, it doesn't use Android built-in functionality like package manager, services, or anything. It just runs shell commands to do everything. That's interesting, that's common throughout the whole software. But basically, next thing it can do, case 2, is it can also uninstall a package. And this is really, really important for them, apparently, because if the PM uninstall package does not succeed, they check the results, they actually try to remount the system directory, which is actually usually read-only. They remount it read-write. They remove the application from the system folder, and then they remount back to read-only. So they're trying really, really hard to make sure if they get the instruction to remove a package, that it's no longer there. Wow, this is going real fast. So basically, it can also disable the package. I don't know for what reasons, and it can also enable a package. Now I'll be talking really, really fast, just running through everything. So basically, what this means is AddOps can install on your device remotely any APKs they wish, and they can install it on a specific device because they know all the identification numbers that are sent along with the request. They know which user, on which network, in which country. They also have the geographic coordinates and everything. Then there's like nasty package. The nasty one, the previous, what we've seen previously was not nasty enough. Basically, there's all kinds of strings, blah, 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 some timers, the sleep timers, periodic kind of things they do. And in plain text, in the source code, three more URLs, which we'll see soon enough as well. But basically, this package is the one that CryptoWire's report talks about. It basically collects data from the phone, dumps it in JSON files, puts in a zip file, encrypts it, actually encrypts it using the encryption method, and is sent over plain HTTP again. But it's encrypted. But the passphrase and the initialization vector is hard-coded in the source. So interesting approach. Anyway, and then another thing, strings they're sending along with the request is these funny project names. So from the good device we had, it was like AddOps MTK, blah, blah, blah number. This one, I don't remember from where we got it, but it has like AddOps custom, another like some custom product names, project names. And the bad one really, really yeah, it was also a custom thing, custom project. So you can make whatever conclusions you want from that. But another thing CryptoWire mentioned, they mentioned IP addresses where the connections are being made to. So 2 IP addresses I want you to remember is like this one. Well, not remember, but notice there's 2. And later, like this year, January, at the end of the January of this year, I did some passive DNS research, digging around, and we see this is the first IP address we just saw. This is the second one. This supposedly is a bad CNC where the bad stuff happens. This is a good one. What we learned from this PDNS, this is October, this like gray column here is like October 28. This is when like they cut basically these 3 domains. They cut them from that IP address and they move them straight to this address. The other one is done actually later, and basically by the November 30, everything is moved away from those IP addresses. Here's a table. Later you can study it, but basically this is one IP address we see. It's moved first, October 28, 7:55. You see by 8:11, it's like 15 minutes or so. That's when those IP addresses, this mapping basically is actually gone, not seen ever after. The other bad IP address is basically those domains are moved somewhere else. They are moved on November 15, and another thing is the funny part is there's 2 more domains on this IP address. They are moved away from this IP address on November 15, but they only appear again on the internet only 15 days later. And basically all others, they are moved. And basically from last seen, October 28, and by the November 15, they're all gone. And then there's another, the CNC we saw, photo controlled future CN. It's still running. I checked it like, well, not today, a few days back. It's still running. It's still serving requests. It's still responding. It's still working. But the thing is, this is actually older firmware, not the one that was mentioned in the CryptoWire. And this IP address was not mentioned in the report, so you may wonder. So basically, as soon as they learn about it, add-ups come up actually on December. I did check, like the frequent asked questions were released on December 5 to mitigate, to explain to people what actually happened. And what they say is certain blue devices inadvertently were actually affected. So I'll have to run through all of these because there are quite a few. But supposedly only version 5 is affected and only certain blue devices. So what happened? They actually I'll have to only show you only the funny ones. They talk about all kinds of information that has been collected, and then they explain some of it, and they do not explain some other data. And sometimes CryptoWire reports that bodies of text messages were included and contact lists were transmitted, and the ADOP says that that's not actually true, and the data from the data it is not possible to identify a specific user, which is actually lies. Again, user's contact list was also not part of the collected data, but it's in the logs, it's in the traffic, so they're actually lying. So they're using HTTPS channels in version 5, but not in previous versions. So what safeguards do they have is that they always talk about encryption, compressing, no clear text, blah, blah, blah. Everything, they throw everything at the user so that they learn all the crypto lingo and they must be assured that everything is safe and everything is good. And another thing is, they say sensitive data such as SMS messages was further encrypted before compression and blah, blah, blah. But in the previous questions, they said only SMS frequency data was actually collected. So quite a few contradictions there. This one is like most funny one, actually. The data was transferred to an internal secure server, cannot be accessed remotely. And actually, it's a tier 4 data center and is physically isolated from external contact. So my first reaction is like they have like a data center in space, like physically detached. Nobody can get there. Anyway, more about proxy servers, firewalls, secure public key authentication through everything as a user. And did anybody else have access to the data? No, ADOPS has not shared the data with anybody, including any government agencies or private parties. Rest assured, no government has ever seen it. And they also refer to the incident as data collection issue on October 28, and then they wiped all the data. But then, why delete the data if they're using it for provisioning and everything? So basically, they're contradicting themselves in the frequently asked questions. So data was encrypted, never decompressed, decrypted, or accessed anywhere. It was just a bug that it was even there. And they have not done anything to the data, no files were opened, blah, 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 except all the data was put into one file, and you could not actually get access to one piece of data without actually having other pieces of data as well. So, another one, since being in contact on this October 28th, it has taken a number of steps which were not a priority before that. And blah, blah, blah. No time. So they're working with Blue, and they only mentioned that only these few devices are actually affected. And we actually, our Swiss colleagues in Swiss CERT, they did using the decryption key and initialization vectors from traffic, they extracted communications, and we saw that device identifying information was also being sent. So we actually, from real data, we saw that at least, I mean, it was not done over a long period, but at least 150 different devices were actually affected. So they claim that only 3 of them, and from only one manufacturer, that's complete lies. Anyway, conclusions. I already said, not only the devices were affected, they have been at it way longer than they admit. Older devices are not even mentioned, and they are not getting any updates. Another conclusion is you do not actually own your device. It's manufacturer who owns your device. Actually, it doesn't matter whether it's like another Chinese company. So Google, Apple, all the big companies, their devices, they are also providing firmware, and they can do whatever with their phones, what they want. So in the end, it boils down to where do you place your trust? And you have to choose wisely. So what can we do? Don't trust just randomly anyone. Just don't buy like devices from unknown, no names. Don't buy cheap stuff, because that way you are actually incentivizing them to actually make more of them. So, and in our case, we collaborated with just 5, and they are actually switching to another firmware service provider. So that's a big success in our case. So, finally, I hope I made it.
Let's give an applause to the marathon that Janis just ran. We can take one question if there is someone that has a question. Okay, one question.
Thanks for presentation. Quick question. Have you ever published the list of devices? Because obviously just 5 is the local one. For new ones, it's going to be fine. What about the existing ones? Thanks.
Actually, no, we have not published, and we do not want to publish because, I mean, we don't know what people are going to put, what context people are going to place that list in, you know. And we just, it's not about specific devices that actually matter. It's that basically cheap devices that use Adobe software, and there's way like 150 at least, instead of the ones that were mentioned on the Adobe's website. So it's about lying. It's about that our vendor actually lies to us. It's not about the specific devices. But if you want, under an NDA, if you contact me, I can give you the list if you want. But it's basically not public, no.
Right, well, thank you so much. Let's give again an applause to Janis and some sweets for you.
Oh, okay, thank you.
You have earned them.
Thank you.